Hey, welcome back everyone. So today I have a special video in store for you. So I'm going to show you how you can avoid using these large DAX statements and not having to write them, but instead I'll show you how you can use helper columns to get the same end result, but also provide you 4 reasons on why the helper columns are better to use than these long DAX statements. But before we get into that, hit that subscribe button down below, leave a like, leave a comment. If you have a personal preference on what you'd like me to demo as well, give me a shout, let me know what you'd like to see, and I'll create that video for you as well. With that said, let's dive in. All right, so the first thing I want to do is talk about the 4 reasons why. So the first one's going to be simplifying your complex logic. So rather than writing a very long DAX statement and having to figure out how you need to bracket things, what should go where, what DAX functions to really utilize, a helper column is going to show you how you can take the data from table view and then build a column to support slow transformations to get your end result. It also provides you a row by row analysis, meaning now you have a data point tied to every row in case there's members or sales or whatever the table of data that you're looking at. Every person or row now has a value associated with it as well. So the third thing is going to be performance optimization. So rather than using these long DAX functions, what we're going to do is now reduce the amount of processing time because those DAX functions can rely on slicers, filters, other DAX expressions as well, and it can just take some more time to process, and Power BI is not known for its optimization as well. So we're just going to support Power BI honestly by using helper columns to break out the steps in smaller sequences to still achieve the same end result. This also enhances usability on tables and charts, right? So now we can use those helper columns that we're going to create to use as filters, use as slicers if we need to, and then create dynamic charts as well if desired. So what I want to do now is take you to a product that I'm currently working on. This is called the Next Gen HR Pro Dashboard, and the table that we're looking at is called Absence Analytics. So I have a bunch of data here, right? I have by name data, I got dates, so begin dates, end dates. I have types of absences, reason descriptions for each one. So what I want to do is take you to the last 4 columns more than anything else. So what I did here was I used a date diff calculated column. So essentially what I did was figure out the difference between the begin date and end date of this person's absence, and I just wrote how many days of absence. And then what this helped me achieve was the average days of absence measure that I have listed here. So now going back, we have another custom column that we created. This is going to show me a binary result, so 0 or 1, right? If the absence is outside of the continental US. So what I did here was I just put a bunch of different states, their 2-letter identifiers, and then just gave me a 0 or 1, 1 being yes, it's outside the US, based upon that individual request. Now I know I haven't covered all these different DAX expressions I'm going through right now, but I will at a later time. But what this helped me achieve was the outside continental US report. So now I can easily identify how many people are going to which country. It also helps me identify who's going within the continental US as well by state. An additional benefit is going to be if I right click on this data point and I show data point as table, I can now receive a by name result of who's going to that certain location. Now, if you just did a long DAX expression on the surface and you didn't do these helper columns, you're not going to be able to get that by name result. So that's the difference we're looking at with calculated columns, because now we're putting an individual value next to a member. So the next one is going to be absence workflow. So we're just essentially changing the code to a long name definition so it's easily understood at the user level, such as approved, canceled, denied, etc. And this will help with identifying what type of absences are approved, denied, or pending. And there's some I filtered out intentionally, but this will help you pinpoint data based upon where your unit may be at. And then you could also inquire further on, hey, why is it denied? Why are they still pending? Which ones were approved so we can forecast where we're at availability wise in the future. And then the last one I made is, are they currently on absence? So yes or no binary once again. So this is just going to tell me, does the current absence have today's date within it, within the parameter of the start date and end date. Now, these are all building blocks like we talked about, right? So we want to look at approved, and then we also want to look at, hey, who's currently on absence as well, so that we can see, hey, they're approved, they're on absence right now. Or there's some that are probably pending that are supposed to be on absence. So now we got to figure out, hey, what's going on? What's the issue? Now we have another chart for that as well, and we can do the same thing, which is show data point as table. Now, if you want to figure out who's currently on absence, all you have to do is click on this. So like I said earlier, a benefit is going to be performance optimization. So it's going to take less processing time. You have your row by row analysis as well. And now people can easily go into this table within table view, and they can clearly identify what type of calculation was made rather than trying to decipher a very long DAX statement. All right, so that's all I have for today, folks. Let me know in the comments below if it was helpful for you. And with that said, thanks for watching.